Hello students, welcome to today's session of chemistry. As we all know, we have started study of 7th lesson of your syllabus, that is modern periodic table. Before starting today's session, we will just revise what we learned in the previous session. In the previous session, we started study of periodic trends in physical properties. And the properties we are going to study are atomic and ionic radius, ionization enthalpy, electronegativity, electron gain enthalpy. In the previous session, we learned about the basic properties such as atomic and ionic radius, and the second one, ionization enthalpy. So, what is atomic radius? It is 1/2 of the internuclear distance between two adjacent atoms of a metal or two single bonded atoms of a non-metal. Same with the ionic radius. And what is the trend of atomic radius? Across a period, as the electron is added to the same shell, effective nuclear charge increases and hence the atomic radius decreases. And down the group, every time a new shell is added and hence effective nuclear charge decreases and atomic radius increases. Same trend is observed in case of ionic radius, where we learned about cations and anions also. What are cations? The positively charged ions, and anions, the negatively charged ions. Cation is smaller than the atom, while anion is larger than the corresponding atom. And about periodic trends, they also show the same periodic trend as that of atomic radius. Second property we learned about is ionization enthalpy. What is ionization enthalpy? It is actually the energy required to remove an electron from an isolated gaseous atom in its ground state. That is called as ionization enthalpy. And the energy required to remove first electron is first ionization enthalpy. The one which is required to remove second electron is second ionization enthalpy, and so on. What is the periodic trend of ionization enthalpy? On moving across a period, the ionization enthalpy value increases. Why? Because atomic radius decreases, effective nuclear charge increases. Down the group, ionic radius increases, atomic radius increases, and hence effective nuclear charge decreases, and the periodic trend of ionization enthalpy, it also decreases down the group. So we learned this much in the previous session. Now in today's session, we are going to learn about the remaining properties and their trends. Which are the remaining properties then? Electron gain enthalpy, first one, and the second one is electronegativity. So we are going to consider the periodic trends in physical properties of electron gain enthalpy and electronegativity in this session. So let us begin with the first property of the today's session, that is electron gain enthalpy. Now we learned about ionization enthalpy. That is also an energy. Same way, electron gain enthalpy is also a kind of energy. While removing an electron, an energy we have to supply. That means ionization enthalpy is the energy required to remove an electron. And as the energy needed to be supplied, it is always positive. But electron gain enthalpy can be positive as well as negative. So addition of an electron to a neutral atom results in the formation of an ion. There should be a minus charge here, that I forgot, X minus. So X becomes X minus by addition of an electron. So the enthalpy change that takes place when an electron is added to an isolated gaseous atom. In its ground state, it is called as electron gain enthalpy, delta EGH. We write delta IH about enthalpy of, that is ionization enthalpy. Here electron gain enthalpy. So delta subscript EG H. H is enthalpy. And it is electron gain enthalpy, hence EG is there. So the enthalpy change, delta change. The enthalpy change that takes place when an electron is added to an isolated gaseous atom in its ground state, it is called as electron gain enthalpy. It is actually a quantitative measure of the ease with which an atom adds an electron, forming the anion. In short, we can say the energy change that takes place during the addition of an electron while converting a neutral atom into an ion, we can say. And it is quantitatively measured, and the unit for that is kilojoule per mole. So the equation can be shown like this: neutral gaseous atom plus an electron is added, and that X becomes X minus. And it is delta EGH, whatever the quantity comes, that is electron gain enthalpy. It may be positive or negative, depending upon whether the process of adding electron is endothermic or exothermic. You see, ionization enthalpy is always positive because energy needed to be supplied. But about electron gain enthalpy, we can't say that. It may be positive or negative. That sign depends on whether the process is endothermic or exothermic. What is endothermic? When endo and exo, when the energy is absorbed, the process is called endothermic process. And when the energy is released, it is called exothermic. And endothermic, energy has to be supplied, has to be absorbed, given to that reaction, and hence it has positive sign. And when the energy is released by addition of electron, that is shown by negative sign. So delta EGH may be negative or positive depending upon whether the process is endothermic or exothermic. Now, if we compare between all the groups, then elements of group 17 have very high negative values of electron gain enthalpy. Negative values, that means the process is exothermic. That means when they add an electron, a large amount of energy is released. Why? Because 17th group elements, that means preceding to noble gas elements, and they are all halogens. There is only need of one electron in the outermost shell, because if we see the electronic configuration of 17th group elements, it is Ns2Np5, and when it becomes Ns2Np6, they attain noble gas configuration, and for that they are tremendously eager, or easily they add electron in their outermost shell because they attain noble gas configuration. Hence, they show very high negative values of electron gain enthalpy because electron is easily added to them. Elements of group 18, that means noble gases, they exhibit high positive values for electron gain enthalpy because as they have stable electronic configuration, it is very, very difficult to add an electron in their outermost shell. Hence, they show high positive values. So, nearby two groups, 17th group elements show highest negative values, while the 18th group elements show highest positive electron gain enthalpies, as they can't add an electron in their outermost shell. On the other hand, the alkali metals, that means group 1, S block, first group, to the extreme left. 17th group and 18th group, extreme right. Extreme left, that is first group elements, those are called as alkali metals. They have very low negative electron gain enthalpy values. very low negative electron. Negative, that means very less energy is released when an electron is added, because alkali metals have electronic configuration, general electronic configuration NS1. That means they require only one electron to gain the, they require to remove only one electron from the outermost shell, because outermost shell, it has a capacity to accommodate 8 electrons and they have only one electron in the outermost shell. If they donate that electron, the inner core, the inner shell next to the valence shell has completed octet and they become stable. So alkali metals have a tendency to donate electron, which is there in the outermost shell. Only one electron is there. Hence, these metals, they show very low negative electron gain enthalpy values, because they have tendency to donate electron and not accept the electron. So, they don't release any energy. In general, electron gain enthalpies are largely negative for elements of the upper right of the periodic table. That means non-metals, in short we can say. Upper left, because upper left, that means noble gases and all those elements, excluding the group 18 of the noble gases. So, only 18 groups, if we exclude that, if we avoid that, before that is 17, before that is 16, and upper left corner, that means upper corner that belongs to non-metals. So, upper right, upper right, that means P block corner. We have seen the periodic table, those are non-metals. So they have large negative values, because these are the elements in which the outermost shell requires either 1 or 2 or 3 electrons, and they are eager to accept those electrons. Hence, large amount of energy is released by the addition of electrons, and hence they have large negative values. Overall trend, we will say now. The overall trend shows that electron gain enthalpy becomes more and more negative with increase of atomic number along the period, up to the second last element. If we move across a period, the negative, more and more negative value we will get with increase of atomic number up to group 17. Because reason is because of the increase in the effective nuclear charge across the period, and it becomes more and more easy to add electron to a smaller atom. Hence, along overall trend is across a period, the negative electron gain values increase up to group 17. Down the group, what happens to electron gain enthalpy? The electron, as the atomic radius increases, it becomes more and more difficult to add an electron in the outermost shell. Hence, the electron gain enthalpy becomes lesser and lesser negative, because when an electron is added, energy is released, and that becomes lesser and lesser. So, as we move down the group, the electron gain enthalpy value becomes less negative. Understood? So, this is all about electron gain enthalpy. Now, second property is electronegativity. What is an electronegativity means? Suppose a covalent bond is formed between two similar atoms like hydrogen and hydrogen. Then a covalent bond is formed by, as you know, is formed by sharing of electrons. So, when the bond is formed between two similar atoms, the electron pair is shared equally between two atoms. We have seen the covalently bonded atom in the previous session. where I have shown you how atomic radius is measured and in which I have shown you chlorine atom. So when a covalent bond is formed between two similar atoms like chlorine, like hydrogen, the electron cloud is shared equally between these two atoms. But when a covalent bond is formed between electropositive and electronegative element, or we can say a metal and a non-metal. That means suppose a bond is formed between hydrogen and chlorine. What happens to hydrogen? The bond usually it is formed by sharing of electrons. So hydrogen shares one electron, chlorine shares one electron, but still chlorine has a tendency, as it needs only one electron to complete its outermost shell, and hydrogen is eager to donate the electron. The cloud between these two opposite atoms is shared unequally. That means chlorine shows its power, or chlorine shows its tendency to attract that shared paired electron towards itself, and the electron cloud gets shifted towards chlorine, and along with that covalent bond it gets a partial negative charge on it, and hydrogen gets equal partial positive charge on it. And this tendency of attracting the covalently bonded pair towards itself is called electronegativity. So, this is the definition of electronegativity. The ability of a covalently bonded atom to attract the shared electrons towards itself is called electronegativity. When two atoms of different elements form covalent bond, then this happens. The electron pair is shared unequally. And this electronegativity depends upon the effective nuclear charge experienced by electron involved in the formation of the covalent bond. Electronegativity increases as we move across the period, that is the trend. Why? Electronegativity increases as we move across the period. Reason is, this is because the effective nuclear charge increases steadily across the period. We have seen this property. As we move from left to right, effective nuclear charge increases, atomic radius decreases, and hence the tendency to attract the shared pair electron increases on moving across the period. What happens to this electronegativity down the group? The electronegativity decreases down the group. Why? This is because the atomic radius decreases. The size of the valence shell, atomic radius increases down the group. The size of the valence shell goes on increasing. The shielding effect of the core electron goes on increasing as the number is increasing. And in turn, the effective nuclear charge decreases down the group. These are the two reasons. Every time when in the exam, when you are asked to write the periodic trend of any property, then you have to explain what exactly means or the definition of that property and then the trends. If the question is for 3 marks, if the question is for 2 marks, explain the trend of electronegativity. Then you have to write what happens across a period, what happens down the group, and why. Explanation. That will give you 2 marks. So this is all about electronegativity, and the first property is electron gain enthalpy and their trends. Electronegativity predicts the nature of the bond or how strong is the force of attraction that holds two atoms together. As I told you, because of the electronegativity, the two atoms are bonded by a covalent bond, but a partial charge or partial ionic character is also developed because of the electronegativity difference between the covalently bonded atoms if they are different than each other. and because of that they get the bond becomes more strong. Understood? So this is all about today's session. Now the assignment. Explain periodic trends in electron gain enthalpy and electronegativity. I told you just to explain. Hence, first thing, write down the definition and then across a period down the group along with the reason. You see, the assignments are a bit, you have to write a bit more, but these assignments are as if your notes. So keep them properly, send their answers to me, the PDF to me, and keep the papers with you. Those will be helpful while writing the questions in exam. Those are like notes only. Thank you.